why oxygen may be stranger than you think. Every chemist knows the structure of oxygen. It's one of the most basic molecules out there. With a double bond between two nuclei, each of which has two lone pairs, there isn't much of interest about this molecule. Or at least, that's what we're taught at A-level in GCSE chemistry. Even most university courses see little reason to correct you of this notion, so it may surprise you to find it's not entirely true. You see, oxygen does exist in this state. It's called singlet oxygen, but this kind of oxygen glows red due to radioactive decay, and it's nowhere near as common as its cousin, the triplet state oxygen molecule. Triplet state oxygen is a weird molecule, but before I talk too much about it, let's talk a bit about how its properties differ from singlet state oxygen. As it has a lower energy than singlet state, it has a higher bond enthalpy, although this should be apparent given that it's the ground state, or state of lowest energy for the molecule. It's also magnetic, paramagnetic to be exact, as its two free radical electrons have spins, allowing them to create an overall magnetic force. Now, to the molecule itself. As you can see, its bonds are quite unconventional. We have the standard sigma bond in the middle, that much is unchanged, yet we also have two pi bonds as opposed to one, and that these pi bonds are unusual as they have 3 electrons per bond. As you would imagine, this extra electron makes bond quite a chaotic place, and it's, as such, is only about half as strong as a typical pi bond. However, the sum of these two pi bonds' enthalpies is still larger than the bond enthalpy of a single pi bond in a singlet oxygen. Putting this into a molecular orbital enthalpy diagram, we can see that these two lone electrons are located in an energy level that is still very close to the level they occupy within their constituent atoms whilst they're in their triplet state. While in their singlet state, they are paired and occupy an energy level that is much higher than that of their triplet state. Before we close, allow me to explain why we refer to these states as singlet and triplet. Singlet is simple. It has a single possible spin state, as overall, none of the electrons pairs are spinning due to each electron's partner opposing them. A molecule or atom with a single free electron would be in a doublet state, as it could be spinning one of two possible ways, up or down. A diradical triplet is due to having 2 up spins, 2 down spins, or no overall spin. Thank you for watching, and goodbye.